Hey everybody, how you doing today? So I'm going to do a quick overview here for week 3. I'm finally over the hump, I think, with COVID and not sleeping 15 hours a day. So after this week, we should be able to get back into doing new videos that are not done in NetBeans because IntelliJ is just so much nicer for sure. And then we can kind of break up some of those recordings as well. So we'd love to hear what you think. I kind of go back and forth sometimes. I like the class recordings because they have questions and answers rather than just a short video where I just say a bunch of things and there's no real back and forth. Um, so curious what you'd like, what you prefer there. But so for this week, efficiency of algorithms from chapter 4 is very conceptual. This one is rough. I'm going to admit this is probably one of the worst chapters. It's very foundational though. This idea that we can measure and talk about the performance and the efficiency of our algorithms, both in terms of space and time complexity, is important. And we're going to come back to this idea of measuring these as we look at all these data structures to understand how they perform differently. So it's very conceptual, very low code in terms of what we're working with. Um, for the lab, we're actually going to go out to lead code and look at some of their algorithm problems and pick one and just don't look at the solution. Just read the problem and talk about what you think the time and space complexity of the solution would be. That's all you have to do. And then give me what your reasoning is. So you're going to post that in the forum here. Say, this is what you think. This is why you think that. You need more than just, hey, I think this is an O of n squared solution. Right? You've got to be specific or why you think these sorts of things. And then for your reply, again, ideally we get this all done in the same week. But if you need the extra week, we've got that extra week for the reply there. Or if you get your first post in late, it's for half credit. But ideally, we're keeping up doing the additional post and reply in the first week. But I've got it out there, so we've got a little extra time if we need it. Just discuss if you think their explanation is correct or not, and then go look at the editorial solution. You can take a look at this page here, like this add two numbers problem. Here is where it talks about what the solution actually is. So it talks about what the solution looks like, and then saying, hey, this is our complexity analysis for time. It's a max of m or n and a space of constant here because we already have those. And it's saying they don't count the answer as part of the space complexity, which is kind of interesting, but it's still like the same length as the two lists, maybe plus one. So it's not like it's not growing in terms of n, right? It's staying pretty constant in terms of what space we were given is all. All right, so it's the discussion post. There's a quiz on the efficiency of algorithms. This is all from the textbook, so definitely be reading the chapter. I also have those slides available if you like slides. But remember, the slides don't give you everything. This is kind of the Cliff Notes version here, so do dig into the textbook. It's good information. You don't need to memorize anything. Just know where to go look for more information. And then we're finishing up Project 1 this week. So if you have any questions about Project 1, let me know. Make sure you do also post that self-assessment. And let me know if you have any questions or concerns. And I'll see you folks around. Thanks.